Today we're going to be taking a look at how to cut undercut surfaces in Mastercam. So right now we're looking at a surface that is basically the shape of a cone. And most of the time when you're driving a surface toolpath in Mastercam, you would be cutting on the outside of this shape. If, however, you want to try and cut a surface with undercuts, there's only a couple of ways to do it in Mastercam. So the two toolpaths that support undercutting are Surface Finish Flowline. Let me go up to the toolpath menu here. We're in Mill, by the way. So Surface Finish Flowline and Surface Finish Contour. So both of these toolpaths here will support undercuts on surfaces. My preference is to use Flowline if I'm trying to cut a single surface. If you are trying to cut more than one surface, at that point I think your best bet is going to be Surface Finish Contour. So let's take a look at how we create one of these toolpaths. I've got some toolpaths already created, but I kind of think that's cheating. So what we're going to do is recreate both of these toolpaths live so that you can see how I'm doing it. Let's create a new toolpath group just to help keep them separate. And now I'll select Surface Finish Flowline. Now in order for Flowline to work, one of the things that you should probably do, I'm going to unshade my surface. One thing that I think is wise to do, at least initially, is to change your surface normal. The surface normal is the positive side of the surface, and in general that is the side that you're going to cut, or the side that is going to generate toolpath motion. So as we look at this part here, let me just change this color real quick before I get started because it might make it easier to see this. If I change this surface to red and it's in shaded mode, you'll notice that I can't see which side of the surface is positive or negative, which side is the normal side. But if I unshade the surface, the normal side of the surface is going to be shown in the surface's actual color. And the back side of the surface will get shown in whatever your surface normal color display is set to. Typically that's going to be a dark gray. If I want to see that a little bit better, I can also take the surface, I'm going to right-click on Attributes and change the surface density. And all that changes is the number of display lines in the unshaded mode. So here pretty clearly you can see, if we look from the top down, the normal of this surface is on the inside of the cone. So that's where we'll be cutting. All right, now that I've got that done, we're going to do Toolpaths, Surface Finish, Flowline. I'll select this surface as my drive surface, and now we're going to go and look at the Flowline curves. When I click on the Flowline button here for flow, you can see that Mastercam is now going to machine on the inside of the surface here. And this arrow tells us the direction that our cut is going to go and our step is going to go. So in this case, our cut direction is cutting, kind of spiraling around the surface or slicing it, and then our step direction is stepping down, and you'll notice we're starting from the top. I can change all of these options here. For example, I can change cut direction, so we're cutting actually up and down the cone instead of around the cone. Or I can change the step direction so that we're starting from the bottom and working our way up. So in this case, I will do top-down though. So there's how we're cutting, and I'll select OK. Now, depending on the degree of undercut, there are two types of tools that can do undercutting. My personal favorite is the slotting saw with a full radius. So if we look at this thing, it's a slot mill, and it's defined as a full radius. And this one happens to be a 2-inch diameter. I believe this is a 4-inch cone at the bottom, and it's a 1/4-inch flute. So we're going to have a 125 full radius on the end. The other type that will do it is lollipop end mill, but you're limited in the amount of degrees that you can go underneath the surface. So we've got our tool selected, surface parameters, we're starting up above the piece at 4 inches. It's like 2.5 inches high, retracting to 3 inches absolute. I'm going to start with the default settings so you can kind of see what you're going to do here. Make sure, okay, so all these are, again, set to the default settings. And when I do just the default settings, it actually won't allow the toolpath to undercut. So we'll let it process this flowline toolpath, and you can see that we're getting some kind of strange gap motion there, and it's going to crash into our surface and give us a bad result. Let me just change that surface density again. That's better. Okay. So when we set this up for undercutting, we need to adjust the gap settings. So if we go into the gap settings here, gap settings control what happens when the tool is about to do a step down or a step over. So when we look at this toolpath, we're taking slices or using the drive boundary curves of the surface to produce toolpath motion. And what ends up happening is after we complete a pass on this surface, let me change this also. Let's do a 50th step over. That'll help us generate it quicker, and we can take a look at what's going on. When we get to the edge of each slice, so here you can see that we've got some slices that are being cut. Once we get to the edge of the slice there, we're going to need to control that toolpath motion. So under gap settings, there are some check boxes here. Check gap motion for gouge, use plunge, retract rate in gap. This just controls the feed rate that gets used, but this check gap motion for gouge is what is causing this retract to happen. In order to be able to uncheck that checkbox, you have to either use direct or you have to use broken. So if I set this to smooth, well, actually smooth will let me, but follow surfaces has to have check gap motion for gouge set. So follow surfaces we can't do. Smooth in this smooth in this case doesn't make any sense, because this would be if we were going off the edge of a surface, and in this case we're not. We want to stay touching the surface the whole time. So what we'll use here is direct. Since it is just a tapered cone, we can go ahead and do a direct feed motion, and then turn off check gap motion for gouge. By turning off the gouge check, sometimes you also have to turn off this one here, check flowline motion for gouge, but we'll start with the gap. When you turn that off, that will now allow you to produce some nice, clean surface undercutting motion. And everything about this toolpath is great, except for the approach and retract. So we'll get to that in just a second. If we look at this surface finish flow line, and we look at it in backplot, here we're starting on our surface, and actually let me change translucent mode so we can see this. All right, if I backplot this now, you can see that we're starting out okay. I don't like the direct plunge into the cut, but we'll worry about that in a minute. And now, as we make our passes, there's slice 1, there's slice 2, and you can see that it's just making these cuts along the surface and then doing this direct feed motion. There's one more thing that I think we can clean up here before we adjust the lead in and lead out. In addition to zigzag, we also have the option for spiral in flowline. So if you're doing a single surface, this spiral is going to produce some really nice motion. So when we set it to spiral instead of zigzag or one way, now we get this nice toolpath, nice smooth toolpath that just does this constant, almost ramping motion as it goes down this surface. Okay, so now this toolpath is looking really nice. You know, we're getting some good motion. You know, we can adjust the step over, change all those parameters. But the motion itself is looking at kind of exactly what we want. We're taking this slotting mill, full radius, and we're driving it, you know, tangent to the surface that we're cutting. Okay, great. Everything's good except for this approach and retract. So in all of the surface toolpaths, if I go to surface parameters, and I'm speaking about the older style surface finishing toolpaths. So you're not going to see these in the new HFT finish toolpaths, but you will see it for toolpaths like surface finish flowline and surface finish contour. There is an option here on the surface parameters page called direction, and you must enable it with this checkbox. This direction button provides you with some lead-in and lead-out capabilities for a surface toolpath. So I'm going to enable the direction button and click on it so that we can access the direction dialog. And what this provides you with is the initial lead-in entry motion, which is the plunge direction, and the final retract direction, which is the exit motion. So let's look at this first. So plunge direction. Right now, the way that this is set up with a plunge angle of 0 and a plunge length of 5, we're not really getting any motion here. So the way that I like to do this is to set this relative to the cut direction. And the reason I say this is that it depends on if you're going to be transforming or, you know, rotating your coordinate system or not. But if you do it relative to the cut direction, no matter where this surface gets transformed to, your entry and exit motion will still be relative to the surface itself. Sometimes it does make sense to do it relative to the tool plane X direction as well, and you can, you know, experiment to see which one you like better. I'll do cut direction here, and what I'll set is a plunge angle of 0, an XY angle of 0, a plunge length of 0.5. So if we do that, and actually let me do a plunge length of 1 so that we can see it. So with direction enabled, what we now have, and you can see it here, is this 1-inch long lead-in motion. And if I look at it from the top, both of them are going kind of the same direction. Now obviously this is crashing into my surface, but it gives us a good start to be able to adjust from. So what I'll do is go back into the direction. I'm going to change this length actually to 0.5. And now we're going to adjust the XY angle. So this is an XY angle of 0 at the moment relative to the cut direction. So what I'll do here is just try 90. And I'm just adjusting the plunge direction first. So that's 90. So if 0, 90, I want 270. So I'll change this to 270. We'll regenerate the toolpath. And you can see now that I have some nice entry motion to start the cut. Now we just need to fix this exit. So I'll do the same thing here. We've got 180, so I'm either going to need 90 or 270. 270 might be out to the right. Let's check that. Yeah, so we're going to need 90. So here's the directions going out to the right. That's the incorrect way. So we'll change that to 90. Now again, this is relative to the cut direction. So now we've got this nice entry motion that's a lead in. And we can back plot that and see it. So as I step down, there's my first initial point. Now we drop down, and then we do this half-inch lead in until we're tangent with the surface, and then we begin the cutting motion. So now we're actually down on the surface doing our cutting. When we get to the end, I'll go ahead and use restrict drawing here so that we can see just the last bit of this toolpath. We're doing our final plunge down along the bottom of the surface, and then we get to our lead out move. So there's our lead out move. It moves us off the surface so that we can clear the hole. If I look at this from the top, you can see, let's turn off the holder as well. So there's my tool. I'm back in the middle, clearing the walls, and now we'll retract back up. Turn off restrict drawing, and there's the entire toolpath. Okay. So the other thing that I can adjust is the plunge angle. So this is our XY angle that chooses where our entry motion comes from. This is very important. We have to adjust that to get it right. But then we can also play with the plunge angle. So if I do a 10-degree plunge angle, that's 10 degrees positive on the entry, you can now see my tool comes in, and now it does this 10-degree angled ramp motion before it begins the cut. But that's not all. So that's a positive ramp. If I look at that from the front, I can also actually use a negative value here. So if I put in negative 10 degrees as my plunge motion, now it's going to plunge down in, and then you'll notice that my entry motion actually moves the cutter from this lower spot and feeds in on a 10-degree angle until we're tangent. So there's lots of different motion that you can generate using that direction button, and you must use it if you're doing surface undercutting with flowline. Surface finish contour has some other options that can be used, but I also prefer to use the direction option with surface finish contour as well. Okay, so let me go ahead and turn that one off. Now we'll do the same thing, surface finish contour. So toolpaths, surface finish contour. I'm going to select that as my drive surface and select OK. We're going to use that same slotting tool, and I'm going to make sure this is set to the defaults. It's usually 10 and 10. So again, these are all kind of the default settings, and we'll let it generate. Okay, so if I just use the default values, I get a toolpath that's not very good. You know, it's cutting on the inside, it cuts on the outside of the surface, and all of the gap motion is just terrible. Okay, so let's go in and clean it up. Now, in order for us to do motion on the undercut, we have to turn off these gouge checks right here. So this is gap settings. We can define our gap distance, and we need to go ahead and disable check transition motion for gouge and check retract motion for gouge. So we have to disable those in order to allow it to do undercutting. So we'll just make one change at a time here. Now, the other thing that we really want to do is get rid of all this cutting on the outside of the surface. And in order for us to do that, we really, with surface finish contour, need to use a containment boundary. I'll just turn off the toolpath. Now, a containment boundary is typically a wireframe chain that we use to tell Mastercam where we want to allow cutting and where we want to restrict cutting. And in this case, because it's just a tapered surface, we can actually just use this circle on the bottom as our boundary. So I'm going to go into the geometry option here for surface finish contour, and I'm going to add a containment boundary. I'll select that one. As long as it's a 2D closed boundary, it will work. And now, under our surface parameters, we can tell it whether we want to allow it to go to the center of the boundary, whether we want to restrict it to be all inside, or whether we want it to go outside. In this case, we do want to restrict it to be inside our boundary. What we're telling it is that we only want tool motion inside the boundary, ignore anything that's outside. And so when we do that, we finally do get some motion that looks pretty good. Okay? Now, what we're getting with this, what looks like a helix that's going down around the outside, this is actually the offset that's happening per pass. So here it says direction of closed contours, and we've got a start length of 0.1. And this start length is spreading out each of these entry points by 100 thousandths. So we can set that to 0 if we want, and that what looks like a helix, which is just the step down, is just going to become a straight line. So there's that start length for you. Now, the other thing that we can do, instead of worrying about start length, is enable spiral limit. Now, what spiral limit will do is, depending on your value that you put in here, any motion with a slice that is less than this value is going to get turned into a spiral. So here our maximum step down is 50 thou. We want to set our spiral limit the same, and what will end up happening is the toolpath will get generated with no step over marks. Now it's just essentially just like our flowline toolpath. It's just becoming helical kind of spiral ramping motion that does our undercutting. So what's the last thing that we need to do now that we're getting some nice clean motion? That's right, we need to adjust the direction. So we'll come in here and enable direction. In this example, I'll just use tool plane x-axis. Now, one of the advantages of tool plane x-axis is that it's going to treat the 0 to 360 degree start, stop point, and direction the same between the entry and exit. That's not true for cut direction. So cut direction is going to be based on which way the cut is going and where it's leaving off on the surface. So you have to be a little careful with that. So tool plane x-axis, we're going to do plunge angle 0, retract angle 0. We're going to do xy 0 and 0. Plunge length on the top we'll do 0.5, and retract length on the bottom we'll do 1.0. So we'll regenerate that, and if we look at it from the top view, there's our entry motion. So it's coming in right here. We don't want that. We want it to come more from the center, so we're going to have to adjust that angle. Now, one of the things that I'll tend to do sometimes is I'll use a long plunge length just to be able to see where that plunge length is easily. So here's 3-inch, 3-inch. I wouldn't use that for the actual toolpath. But if I do that, now I can see I've got a plunge length going this way for my entry of 3 inches. Here's my exit. So what I'm going to do is now adjust that direction XY angle until I get the entry that I need. So there's 0. There's 90. I know 180, 270 is going to be straight up that way. So let's try like 240. Okay. Now my entry motion's almost right, maybe a little too much. How about 230? Now you will get that warning. It's just letting you know, support for undercut, just some stuff about it. So here, I'm almost to the center of my part. Let's go 225. And we'll regenerate it. Bingo. Okay, I like that. Now we'll just adjust the length. So 3 inches, we'll go back to 0.5. And there's a nice entry motion. I can play with it all day to get it exactly on center. Here, as long as it's safe, That's what I'm caring about. So back to this guy as well. Now you'll notice this direction actually started, the top direction started out going to the left, this one's starting out going to the right. So at the exit point, that's how it's seeing 0. So what we're going to do is give it 45. So we'll just start out with 45 degrees and see if we're going the right way. Okay, so 45 was right. That was just a guess on my part. If it was going the opposite way, you know, I would adjust it and use 315 or whatever it needed to be. And now I will change my retract length. Let's try 1 inch. There we go. So there's my entry point, there's my exit point, and they are both near the center of the feature that I'm trying to machine. So, you know, as long as I've got, you know, some clearance on my tool, I probably would have gone in there with a, you know, 3/4 or 1 inch end mill and machined this all the way down so that the only material that's left is this material down here. And of course, you may have to do multiple operations with stock to leave to get it to, you know, do some roughing and finishing if you need it. So if there's a lot of material here, you might have to make multiple copies of these operations and adjust the stock to leave until you get what you need. And part of that is due to the fact that there is no roughing toolpath that I'm aware of that will support undercutting. Maybe surface rough flowline. I haven't tried it in a while. That may support undercutting, but you'll have to play with that. So, okay, so that is our example here of surface finish flowline and surface finish contour supporting undercutting on a fairly simple surface. We're about halfway through our webinar, and we've got some more examples for you of some more kind of some typical aerospace parts that we can apply it to, so you can see it in kind of a real-world application. But at the same time, we also kind of want to do a little bit of Q&A here. So we're going to open it up. Derek, if there are any questions at this point, go ahead and ask them and let me know, and we'll answer some questions, and then we'll move on and look at doing this in more of a real-world application.
Okay, sounds good, Colin. Excellent presentation so far. So everybody out there, now's your chance. Let's try to get in some questions during this short break. And as Colin said, then he's going to take on something that's a little more real-world. So let's see. We have a first question coming in from Bob. And this is the question we always get. Will this video be available to view offline? Yes, we'll produce this video this afternoon, and we will send out a link to everybody here on the webinar, so you will be able to access this video for future reference. Let's see. I have a question coming in from Clifford. How do you pick the positive side of the surface?
Sure. That's a great question. Thanks for the question, Clifford. So here, this particular surface right now, the normal is going on the inside. There are two commands that you can use to change a normal. If you go to the Edit menu, you'll see Edit, Set Normal, and Edit, Change Normal. The Set Normal command is typically used with a group of surfaces, and it allows you to select a bunch of different surfaces, and when you use the command, the normal direction on the surfaces will try to be set to be equal or near to equal to the Z direction of your current construction plane. So whatever tool and construction plane you've got active, if you use set normal, it will try to direct all of the normals of all the surfaces you've got selected towards that Z axis. If you want to do an individual change one at a time, you can use this change normal command. So I'll select change normal, and when I put my cursor on the surface, you'll notice that there's actually this little normal direction arrow that you're going to see pointing there. And when I physically click on the surface, it will reverse that normal for me. You'll notice that it also dirtied all of my toolpaths because I've changed that property of the surface. So you've got to be aware of that. So again, if I click on it again, it will change the normal back. And we'll do a little bit, we'll do a little bit more demonstration of that on the real part that we're going to take a look at. Now, the normal direction to me, it really only matters. I shouldn't say it really only matters. It's a good idea to always set the normal direction before you start machining. Mastercam will still create gouge-free toolpaths on a surface where the normal is reversed, but typically you're going to have to make some adjustments to it. So for example, if I flip the normal to the outside, and then we take our surface finish flow line, click on the geometry button, and click on the flow direction, the default is going to be having the cutting on the normal side of the surface. But there is the option to use the flip offset. So if you click on offset here, we can flip it to the inside, and we can cut the non-normal side of the surface with flow line. So it does allow you to do that, but it is a best practice to always have your surface normal set properly. So in this case, we would recommend going in, changing the normal back to point to the inside, going back into the geometry, and again, adjusting our flow directions. Surface finish contour doesn't care. So I'll regenerate my surface finish flow line, and we'll select surface finish contour. Now again, my normal's pointed to the inside. If I go in, change normal, flip it to the outside, and then I take surface finish contour and regenerate it, it simply won't matter. It's still going to generate a gouge-free toolpath even though we're cutting the back side of the normal of the surface, because the cutting itself is simply controlled by the containment boundary. The containment boundary tells it, I only want to generate motion inside of this circle, and so that's where it's going to do its cutting. But that was a great question. Thanks, Clifford.
Yeah, great. Thanks for the question there, Clifford. So let's see. We have a question coming in from Dwayne. Can you extend the bottom of the surface cutting without creating extra surfaces?
Yes. In order for you to extend that surface, though, it has to be untrimmed. So if it's a trimmed surface, you must first untrim the surface before you're allowed to extend it. We may be able to take a look at that on, I mean, I can do it now because it's already an untrimmed surface. Create surface, extend, half-inch extension there. I'll click on it and extend it, and it makes, you know, one single surface. So the only exception is going to be when you get into some surfaces that are already trimmed. In those cases, you do end up having to generate separate surfaces in some cases, just depending on the geometry. I mean, I could do a whole class on surface manipulation for surface machining. There's a lot that goes into that, but you certainly can extend the surface like I've done here, and then well, actually, let's just show flow line. Right now, if I did my finished contour, it would still be restricted by my boundary, so I'd also have to take this arc and offset it. So if I click on that arc, right now it's a 4-inch diameter. Let me make it a 5-inch diameter. It's still going to remain associated as my containment boundary. Mastercam's smart like that. So we'll go ahead and regenerate both those toolpaths that we just created, and we should get motion that now does go down, in this case another additional 1/2 inch. We've extended that surface. Same thing on the upper part. I can also do the extension here. So create surface, extend, drag that up, and we should be able to regenerate both of these. Okay, so there's that one. Oh, and on this one, I've still got to go in and adjust my offset, because again, I had my surfaces on the inside now, or my normal is on the outside, and I'm trying to cut on the inside, so I've got to adjust that toolpath. Again, best practice, we would want to flip this normal, edit, change normal, flip it to the inside like it should be, and we'll go adjust our flow direction so that it's correctly on the inside. And we'll regenerate both of those. That was a great question. Thanks.
Great. Okay, I have a question coming in from Troy. What feed rate does the direction use?
I believe the feed rate uses the plunge rate, but we should check that. So plunge rate in this case 25, feed rate 3. If I now go in and backplot that, we'll get the Details tab open, and we'll start stepping through the toolpath. So we start at rapid, we feed down at rapid, we feed down at 25, that's our plunge motion, and you'll notice that we're feeding over with the direction at 25. That's still considered our plunge motion. And now, when we start cutting on the surface, we change to our 3 inches a minute. So the direction will use your plunge value there. We get down near the end here, and we'll restrict drawing. And as we finish the cut, we're still at 3, still at 3. So we're coming over here at 3 inches a minute. And now we're in the retract. So it uses the plunge value for the initial entry direction, and then it uses the retract value here for the retract. So you actually get 2 different values. Your plunge is for the entry. So you notice plunge direction, retract direction, and on the toolpath parameters page you've got plunge rate and retract rate. So it's using those values there.
Right. Perfect. Okay. We have a great question. Comment coming in from William. Comment: Rough Pocket will support undercut tools. You can pick a start point. Tool will move to the start point before cutting the pocket, then move back to the start point after cutting the pocket to change to your next depth. You can also disable roughing passes and just output finish passes. That's coming in from Bill Bentrup from CNC Software, the makers of Mastercam there, so we do appreciate that comment, Bill.
Yeah, thanks, Bill. That's great to know.
Mm-hmm. And let's go. We have a let's see. Got a question from Alan. Why doesn't the contour use the lead in and lead out, or the entry and exit arc line?
Well, it is certainly possible to use the entry and exit arc. In this case, I don't think it really makes sense just based on this particular surface. In this case, I would prefer to just use the direction to get the tool into and out of the cut. But we will see that with Surface Finish Contour, we can support using this entry and exit option in order to do the cut. So we'll see that kind of on the next part that we're going to be looking at. And I don't think it'll allow you to enable that. Definitely not with the spiral entry. I know there's another option that we got to set to be able to turn on the entry and exit line. But yes, we can use the entry and exit arc and line motion to support lead in and lead out for Surface Finish Contour. And we'll look at that on our next part.
Okay. Well, with that, Colin, I think why don't we just go ahead and roll into it. We're at 12:30 or 12:40 p.m. out here on the West Coast, 3:40 where you are on the East Coast. So let's go ahead and we'll go right into the next section of this webinar.
That sounds great. Okay, so this is our kind of simple example, and then we've got another example we created that is kind of the more typical part that you're going to see out in industry. So I'll disable translucent, and this is our part. So we've got, you know, kind of a thin wall, aerospace hog out, maybe it's made out of aluminum, and now we're going to take a look at some of the features on this part. So at first blush, this thing looks pretty simple until we take a look at this from the right side, and we realize that we've got a couple of walls that are not straight and they're tipped out. So if I look at this from the right side, this is what we would refer to as an open feature. And it's open because I can machine it from this side, from the top side, but then I can also flip the part over and still get access to this wall. So if I machine it from two sides, I don't have to do any undercutting. If we look at this left wall, however, this has what we refer to as a closed angle. So on the inside here, we have this wall that tips in, and in order to cut it, we have to cut it from the top side, and we have to do some undercutting. So there is a tool, by the way, that will let you examine a solid face or a surface to see what degree that surface is either open or closed, if it's open or undercut, and that is Analyze Dynamic. So if I choose Analyze Dynamic, I can now go click on this solid face, and as I drag my arrow across that face, I'll be able to see changes in the angle of the surface. So this option here on the Analyze Dynamic dialog box will tell you the angle from vertical, and it'll also tell you the minimum radius of curvature. So as I drag, again, this arrow across the surface, we'll start over here, we can see we're about 1.75 degrees, and you'll notice it's also a positive angle. And by the time we get in the middle of the part, we're at 6.681, and then back to the other edge here, we're about 1.75 degrees. Now, if I click off the part and then choose a different face and click on it, now you can see that it actually shows us a negative angle. So that's our first clue that this is an undercut surface. It's showing us the angle from vertical, and it happens to be a negative angle, so we know this is an undercut. I can go over here to this side, same thing. This is an open positive angle, so positive 5.5 degrees. From this side, from the top side, which is where we've got our WCS tool plane set, if I click on this outer wall here, you'll notice again this is a negative angle. So we're either going to have to flip it over to get to it, or we're going to have to do some undercut machining. So let's look at how we would go ahead and machine this undercut. I'm going to select top view here. This is my undercut wall that I have to worry about. And I can use either surface finish flowline or surface finish contour. Okay, so if we use surface finish flowline, that's going to work out pretty well here, hopefully, because it's a single surface. So I can do toolpaths, surface finish, flowline. It says select my drive faces, so I'll choose my solid selection, choose the face option here, and choose this face. When we look at our flowline data, you can see that right now it's starting at the bottom and it's cutting along the wall, so we can choose our cut direction. If we want to cut up and down, I wouldn't recommend that, but we could. And we can also choose whether our start is on the left or right edge, and whether we're starting from the top and working down or starting from the bottom and working up. In this case, I'll start from the top and work down. So surface finish flowline. I want my slot tool, so I'm going to create a new tool. And we want a slot mill. It's going to go ahead and launch our tool wizard. All right, so let's choose our parameters here. We're going to go 1.25 diameter. Say it's 150 thousandths thick. Full radius. And shank diameter, let's just do 0.375. Actually, let's go 0.25. Okay. And 2 inches overall, that's fine. All right, so now we've got our 1.25 slotting tool. We go to our surface parameters. We're going to need to use our direction. And we also want to go into the gap settings and make sure that we're not checking the gap motion for gouge. Okay, we'll use broken in this case. We're going to turn off check retract motion for gouge as well. So we'll turn off the gouge checking. We can use optimize cut order if we want. And let's just set this again to 50 thousandths. Now I realize this isn't probably a value that we'd actually use to finish this wall, but it'll help us generate the toolpath faster just for the demonstration. So we'll let that toolpath go. It's looking okay. We need to do a little bit of adjusting here. So we're going to go back in, and the first thing we're going to do is change our gap size. So the gap size setting controls whether or not the tool retracts when it reaches a gap. So there's two options here. If the motion of the tool, you notice this is the title of this little section right here that I'm outlining. If the motion of the tool is less than the gap size, we're going to keep the tool down using one of these methods. In this case, I'm going to choose smooth. If the motion of the tool is greater than the gap size, we're going to force the retract. And that's actually what's causing this little motion right here, this little retract. This distance here happens to be greater than whatever our gap size definition is. Right now, it's a percentage of our step over, 300%. Our step over is 50 thousandths, so our gap size is about 0.15 inches. I'm going to instead set our gap size to a physical distance, and in this case I'll use 1 inch. So we'll do a 1 inch gap size, and I'm going to set this to smooth for our gap motion, and then I'll regenerate. Now it did say when we regenerated it, it gave us a warning about the gouge checking is not supported for undercut, so we should also disable check flowline motion for gouge. So it says gouge check, flowline off, gap or retract on. These are usually all off. It's giving us a warning, so we'll go back in there, gap, and oh, that's right. When I change it to smooth, it automatically turned that back on for me. I want to make sure that's turned off. So now this should support undercutting, and there's my toolpath. Now at this point, with flowline, I can do a couple of things. If I go back into the gap settings, I can use these tangent options with smooth to extend the entry and exit motion off of the edge of the surfaces. So if I use tangent line length, let's go maybe 0.625 with that, and we'll do a tangent arc radius of 1 inch and a tangent arc angle of 45 degrees. Well, we'll explain what this is in a second. And now I'll regenerate that. And now what we've got is, so in this case it's trying to do the retract motion up this way. We wouldn't want the arc in there. So let's go disable those arcs. We're going to set the tangent arc angle to 0, and we're going to set the tangent arc radius to 0. We're just going to use tangent line. And now we get some motion that's extended off of the edge. Let's look at this from the front view. Fit it to the screen here. We get some motion that's extended tangent off the edge of that undercut surface. So as long as we use enough tangent entry, that could technically work for us. I still like the idea of using direction to get the tool into and out of the cut. Because in reality, this wouldn't be very efficient if we were trying to finish here. We'd probably really want more like 0.1 or maybe 0.15 extension. We do still want to go slightly past the surface, but we don't want to waste too much time, right? So now if I look at this from front, you can see that the motion almost gets to the very edge. Let's go a little bit more. Let's go 0.3. That's a little better. Now we're extending the cut past the surface slightly. We're making the transition to the next cut, and we're continuing on. Okay, so again, typically I would use direction for this. So we'll go back in here, set up direction. Let's do again plunge length 3, 0, 0, and XY 0, 0 relative to the tool plane. So again, I set them big just to see what I've got. All right, my entry motion is coming in this way. I'll adjust that one first. So we'll go 90. See if that's correct, or if we want, nope. So now it's plunging through my wall. Definitely don't want that. We'll go back and adjust that to 270. And that gives me a nice entry motion this way. But what if I don't want it to just come straight in? Well, let's do this. Let's go 355. And what that should give us, if I look from the top view here, is this nice 5-degree kind of lead-in motion right into the part. Now, 3 inches is probably a little excessive, but maybe 1.5 inches. Ooh, maybe we want to do 1.5 inches just to be safe. So I'll regenerate that. If we look in backplot, we can see that we're well clear of that wall. I'll look at it in unshaded view so we can see it a little bit better. There's that wall edge that we're worried about. And now it's just going to drop in and then feed in on that 5-degree entry motion before it begins its cutting. Now it's just going to start cutting my surface. Okay, so now we've got our entry motion done. Let's fix our exit motion. So again, we'll try 90. 90 looks to be about correct. Although let's use 45 instead, so it still goes off to the upper right. And let's do, again, something safe, 1.5, 1.25, make sure we get the cutter out of there. We'll probably do 0.8 since it's 1.2 diameter, but let's be safe. So we've got this nice 5-degree entry motion. It cuts my entire surface. So cut, 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 and then finally we do our exit. And again, I did 45 degrees here. I could have done 5 degrees or 0 just to bring it off straight out. So if I wanted it to come straight out, I could do that as well. So there we've got a nice toolpath for cutting that wall. Okay, so that's all fine and good, and I'm sure that we could do the same thing including this surface here. But let's take it up another level. So I'm going to save that, and we'll turn off the toolpath there. And let's look at a different model. So here's essentially the same part, but now we've got a little bit of an obstacle in the way because we've got some extra surfaces that are here that we need to cut. So really, as long as our cutter can fit in between this surface here and this surface here, we should be good to go. So how can I know what my minimum cutter size is to fit in here? Well, one of the ways that I can do it is by using some wireframe geometry. So if I check, yep, I do have wireframe turned on. Okay, good. And what I'll do now is create, actually let me do this. I'm going to select all wireframe geometry and then use hide, which is Alt-E. And we're going to grab this color so that you can all see it and make it something visible. That's better. Okay. So now what we're going to do is take that line, and we're going to take that line and just look at these two. And now what we could do, analyze distance, sure. So analyze distance, or we could do create line closest. In this case, analyze distance. If I just click on that line and that line, it'll tell me the minimum distance, 1.114 in Y. Now keep in mind though, that's to the bottom edge of this radius. So as long as the center portion of our cutter, not including the fillets, is less than that, we should be okay. So what I'll do, we've got our 1.25 slitting saw, but keep in mind that, what is this, 150 thousandths thick means there are two 75 thou radii on either end. So that actually shrinks down the total diameter here. Now, we may actually want to use a slightly smaller tool, but that's also going to depend on what this fillet radius is here. So if we do Analyze Dynamic, anything, you notice this is a fillet radius of 1/2 inch, so we really need to choose something 1 inch diameter or smaller to be able to successfully cut this. So toolpaths, I'm going to go into Tool Manager, we're going to create a new tool. We'll go with slot mill here, and cutting diameter, let's go ahead and use a 1 inch diameter. It's going to be 0.125 thick. Full radius, shank diameter, let's see what we got here. There we go. All right, shank diameter 0.25. Okay, so there's our tool. Go ahead and finish. And now what we're going to do here, we're going to do a surface finish contour. This won't really work for surface finish flowline. And the reason that it won't work for surface finish flowline is that we have multiple surfaces that we have to try and hit. And chances are that if we try to select all of these surfaces at one time, flowline is not going to be able to match the flow directions and be able to successfully cut these surfaces here. So what we're going to do is look at this from the top view. And what I'll do is just create a rectangle. And I want to make sure that the bottom edge of my rectangle is just beyond the edge of these surfaces here. Go over here. So now I'm basically telling Mastercam, oh, let me do that as create rectangle, that'll help. So let's go Z depth, 2 inches, and let's create a rectangle. And turn off surface, there we go. And so we're going to use this as our containment boundary and tell Mastercam that we want to keep the tool all the way inside that boundary. So I'll do toolpaths, surface finish, contour, and now I'm going to select my drive surfaces. I'm going to choose all these surfaces here. Okay, and I'll choose my containment boundary. I want my tool to stay fully inside that boundary. We're going to use our 1 inch tool. Compensate to the inside, so tool containment, we're going to compensate to the inside. We're going to do a 50 thou step down just to start. Make sure we turn off our gouge checking. And we'll do zigzag for now. All right, so we do need to make a few changes here. We got broken. So one of the things that's happening, it's trying to wrap around the edges of these surfaces right here. So what I would need to do is either adjust my containment boundary or extend that surface out so that it doesn't try to wrap around the edge. So in that case, I would probably want to put this on a different level and not mess with my actual model, but just to show you, create a surface, untrim. So I'll untrim that surface and untrim that surface there. Okay, I may need to do it to these fillets down here as well. And now I can do create a surface, extend. Let's go 1 inch out that way. Okay, now, but if I do that, I also need to be aware of how much extra I'm going to be cutting on that surface. You have to be a little careful. You may need to go back in there and create a line coming in from this view and trim this surface up just a little bit so that it doesn't end up cutting, you know, too much air here. But we can use these surfaces. If we go back in and look at our geometry, we'll make sure they're selected. Okay, so the other thing that we can do, we may be able to stop that with the rolling motion. So right now it says, at surface or solid face, edge, roll the tool. So if we turn that off to, or if we set that to only between surfaces, that's the other way that we can end up eliminating that motion. But you'll notice that it doesn't allow the rolling around here. So it's kind of a catch-22. It's a trade-off. Let's go ahead and set that back to automatically. But let's go in and make some adjustments to the boundary. So what I'm going to do is use X-form stretch, take my boundary over here, and in this case I'm going to move it X, let's go 1.25. So now if I tell it to stay fully inside that boundary, you'll notice that the tangent edge of my tool is going to get here. It's a 1-inch tool, so as long as we allow it enough room to go beyond the edge of my actual part, we should be good. I'll hit plus there, reply, and now I'm going to do the same thing over here. I'm going to stretch my boundary. Let's go minus 1.25, maybe a little bit more. Minus 1.5. It'll still maintain associativity, so I've still got it selected as my containment boundary. But now by adjusting it to a proper width, I get this nice clean motion. Okay, so again, I may want to go in there and trim that surface a little bit, or maybe undo those trims, you know, and use the original surfaces that I had, but just adjust my boundary. I may be able to get away with that. But over here, where this surface slopes down, it'll probably try to wrap around the edge. See, I got to be careful of that. Okay, so last thing that we would end up doing here is adjusting the direction, but we can also do our entry and exit arc and line. I have to go to broken, but once I go to broken, I can enable the entry, exit, arc, and line. And so here, I can give it, you know, this is my entry, exit. I can tell it allow arc and line outside my boundary, so it will let me get away with that. And now, instead of using the direction and instead of using, you know, instead of having to adjust these surfaces here, I may be able to just do that. So here you can see now I'm getting my entry, exit motion, which technically, if I do this, I don't have to worry about using direction. I can just get away with doing my entry, exit motion, and this will safely enter my tool into the cut, make the cut, and then exit back out. So we can step through that, look at this from the right side. And, you know, we do the cutting. All right, so that is just about going to conclude our demonstration of cutting undercut surfaces using Mastercam.